This video is for lesson 8-2 about perpendicular lines. This is another geometry concept that has connections to algebra class. And I want to remind you that earlier this year we studied parallel lines. Perpendicular lines are two lines intersecting at a right angle. So the lines form a 90-degree angle when they intersect. In figure 8-4, there's a horizontal line in black ink being crossed by a vertical line in black ink, forming a 90-degree angle right there shown by the box. These are perpendicular lines. Perpendicular lines can also be diagonal. So in figure 8-5, there's a line running downhill being crossed by this line, which is running uphill, and they also cross at a 90-degree angle. Those are perpendicular. Let's see if we can discover an algebraic relationship between the slopes of perpendicular lines. In this second figure, figure 8-5, the equation of the line that runs uphill is y equals 2x plus 5. If I scroll up just a little bit, we see that its y-intercept is touching at 5, and its slope is up 2 over 1. The equation of the other line is y equals negative 1/2 x minus 2. So looking at the picture, we see the y-intercept is at minus 2, and the slope is negative 1/2. Down 1 over 2. When you study these two equations, remember that when you're in y equals mx plus b form, the coefficient of x is the slope. So on this equation, the slope is the negative 1/2. Now, what's the mathematical relationship between the number negative 1/2 and the number positive 2? They are negative reciprocals. This number is positive, this one's negative. That means they're negatives or opposites of each other. They're also reciprocals because this is like 2 over 1 and this one's flipped upside down, 1 over 2. So let's take a look at the perpendicular lines theorem. Two diagonal lines are perpendicular if the product of their slopes is negative 1. This is a mathematical way of saying that the slopes are negative reciprocals. Think about our example. The slope of one line was 2. The slope of the other line was negative 1/2. When you multiply these slopes, you get negative 1. Here's another example. Let's say that one line had a slope of 1/4. The negative reciprocal of that is negative 4 over 1. When you multiply those together, you get negative 1. Negative reciprocals are two numbers that when multiplied, you get negative 1. So we can use that idea to work with perpendicular lines in algebra class. Here's an example problem. Determine an equation of a line that goes through this point, and our line is perpendicular to the line given by this equation. Well, what do we know about perpendicular lines? What do we know about the slopes of perpendicular lines? From this lesson, we know that they are negative reciprocals. In step 1, let's find the slope of this equation. It's in standard form, so its slope is found by the formula negative a over b. We learned this in an earlier chapter this year. This is negative 2 over 3. Okay, that's the slope of this equation. Now in step 2, let's get the slope of a perpendicular line. So I'm using this little upside down T symbol to mean the word perpendicular. This is the geometry symbol that means perpendicular. It's going to be the negative reciprocal of that number. What is the negative reciprocal of negative 2/3? It's positive 3 over 2. You can check that you're right because if you times these together, you do get negative 1. Now in step 3, let's create our equation. Think about what we have to work with. We have a point and we have a slope. What equation form do you use when you have a point and a slope? You use point-slope form. The formula for point-slope form is y minus y1 equals, is this looking familiar yet? M times x minus x1. The point that we're given is our x1 and y1. So we have y minus -1 equals, now what are you filling for m? 3/2. And then we have x minus, what do you fill in for x1? What's the x coordinate of the point given to us? It's 3. Here's our equation. Now we can simplify it, make it look a little nicer by fixing this negative right there. It would look better if we wrote y plus 1 equals 3/2 times x minus 3. Here's another example. What is the slope of any line perpendicular to a line that goes through these 2 points? Well, first, let's find the slope of the line that goes through those points. So let's use the slope formula. y2 minus y1 over x2 minus x1. What's y2? What's the y coordinate of the second ordered pair? It's 8. What's y1? It's 4. Okay, now our x's. What's x2? -3. What's x1? It's -1. This makes 4 over -2, which is equal to -2. Be really careful when subtracting negatives. You might want to use a calculator on this to make sure you don't get it wrong. Okay, we're not done. What we have done is we found the slope of a line through the 2 points. But what's the question ask us? What's the slope of a perpendicular line? So that'll be our step 2. Let's get the slope of a perpendicular. That's what my symbols mean. M means slope, and this little thing here means perpendicular. What's the connection between that slope, -2, and the slope of a perpendicular? What's the main idea from today's lesson? They're negative reciprocals. So we want positive 1/2. I've changed the sign from negative to positive, and I flipped over the 2. Next example, use slopes to prove that the figure formed by segments connecting these 3 dots is a right triangle. Well, first let's draw the picture. So over 3 up 4, here's point A, and then 0, 6. Here is point B, and then -4, 0. Here's point C, and then let's carefully draw in segments. We want to show that this is a right triangle, meaning that it has a 90-degree angle. Now, which angle appears to you to be 90 degrees? Is it in here? Is it in here? Or is it up here? Which one looks 90 to you? Hopefully you agree that it's this one. Okay, if we want to prove that this is a 90-degree angle, then we need to show that segment CB is perpendicular to segment BA. And we can show that using slopes. First, let's find the slope of CB. Then, let's find the slope of BA. These would be perpendicular to each other if they're negative reciprocals. Okay, let's focus on finding the slope of CB. We want to go from B to C. How do the y values change? How do the x values change? From 6 to 0, it has decreased by 6. From 0 to -4, it has decreased by 4. Now reduce this. It's 3 over 2. Okay, now let's figure out the slope of BA. We're going to look at A and B and see how do the y's change, how do the x's change. So from 4 to 6, the y's increase by 2. From 3 to 0, the x's decrease by 3. This is -2/3. Now, are those 2 segments perpendicular? What is it about these 2 slopes that allow us to say that those are perpendicular? They are negative reciprocals. Let's summarize the lesson. We discussed perpendicular lines, which are 2 lines that cross each other at a 90-degree angle. The slope of perpendicular lines are negative reciprocals. There is one special case, a horizontal line crossed by a vertical line. The slope of a horizontal line is 0. The slope of a vertical line is undefined. So that's our one situation where you won't be able to find a negative reciprocal.